Uh, so this is supposed to be kind of an interactive workshop, at least that's what I was told to prepare for. But it might turn into a live demo since we don't have desks where people can just open their laptops and do some stuff hands-on, but maybe we can. So the project that I'm going to present is called Get Login, which is a user account management / login system primarily for Web3 dApps, but it is actually done in such a way that it matches the Web2 experience and standards as closely as possible, so you can actually use your on-chain identity even for Web2 applications. So it is made compatible with OAuth version 2 and also with WebLogin. So this is the GitHub repository, and you find two repos there. So one is the module itself, login, and the other is an example dApp, which we're going to actually see in action. So this guy here, so it's OpenID Connect and OAuth 2 compatible, and eventually you will be able to use all sorts of key management devices. So you could use your MetaMask account, you could use your hardware key, or you can also use a simple username and password-based authentication. And the whole idea is to make it so transparent to end users that they don't even need to know that there's some Ethereum magic going on behind the scenes and under the hood. I believe that we have successfully solved the zero ETH onboarding problem. So this is an invitation-based system. But the actual rules and conditions of, handing out invites is up to the application developer. So you can build this into your dApp and then, set up your own rules. I'm not the author of this project, so I participated in architecting it and I funded it, but the principal author is Igor, so it's mostly his work. And if you are interested in very deep technical details, then he's the right person to ask. And I'm just going to give a high-level overview of what it does. And probably given the format that we ended up having, it's best to start with a live demo, although I encourage everybody who has a laptop online to kind of try to get your hands dirty, and I will actually show QR codes so that you can follow URLs of your own, and we can maybe try, getting an invitation, signing up, and things like that. So this thing is deployed on Swarm. So this is not critically dependent on Swarm. You don't have to use it with Swarm, but it was designed very much with Swarm in mind. So it's a Swarm-friendly application. And the particular instance on the web gateway is here. So can you use this QR code? Just try. You should see something like this. Okay. So I'm going to hide the QR code shortly. So you should see something like this. So this is a login window, as you can see. So you can, if you already have a username and the password, you can just log in, which you probably don't. So what you can do is you can sign up, where the sign up means that you have some invitation code which you can use to actually register a username and a password, but it can also arrive as a URL on which you can click. So let's try a example. So I'm going to show a QR code together with an invitation, and maybe, well, let's see if anybody can actually accept it. So that's kind of an experiment here. So here we have the invites. Here we have. So let's try it this way first. So this is an invitation code. This doesn't have the whole URL in it. It's just the invite which you need to copy and paste into the invite window. Let's just try if, I'm wondering if somebody manages to do that. And once we go through all these mechanics, I'm going to show you what actually happens on the blockchain under the hood, because all this is actually blockchain based. So what you're seeing here, this code here, encodes, among other things, the private key of a pre-funded key which only has a little bit of gas money on it, which means that you can send it over reasonably protected channels like chat or email or things like that. And you don't really need to be afraid of somebody exerting too much effort to steal it, because it's not a lot of money, like it's a few cents worth of Ether. Well, this is Rinkaby test Ether, actually. But the idea is that you get this invitation, you click on it, and your dApp is going to be able to send a transaction to the blockchain from this pre-funded key. And the person who invited you is the person who needs to fund your invitation. And hopefully when you're using any system like that, you always have a little bit of Ether lying around in these temporary accounts. And when you log out, you're actually defunding these temporary accounts. So that's like the underlying mechanics of it. So did anybody manage to accept the invitation?
Yeah, mine was not so. My first thing is I was able to scan it, and it said that the transaction was underfunded. And then I tried again, and it said that someone had already invited the invitation.
Okay, so somebody managed. Oh, congratulations.
Did you get the underfunded message then?
I think I'm just on my own page.
Okay, nice.
So what you should see, okay, so this I have further invites. So we can, like after I'm done with the public thing, we can play with it in a private manner. But so basically what you need to get is that you log in, and so you're going to, so you can see that you have some balance up there. You can log out if you want to. And after that, you can actually use dApps or even Web2 applications which authorize this thing to be your user management. So there's an example dApp for which I'm also going to show a QR code. It's, I believe, this guy. So here's a Swarm-hosted dApp. And it will only work for the person who was lucky enough to get invitation. And meanwhile, again, the policy, the mechanics of how you're handing out invitation can be coded up in a smart contract in Solidity or Viper or whatever smart contract language you want. And you can sell them, you can monetize them, you can restrict them. So you can play all sorts of games with the invitation. It's up to you how you're going to grow your network. Yes, you have a question?
I'm not sure if you...
Sorry.
Oh, sure. Well, I'm just asking because you said it was going to be interactive. Interrupt me if you were going to explain that later. But is the so what are you doing with the private key? Is the private key derived from the username and password, or are you generating a private key and storing it locally?
Neither. So what you do is you're generating a private. So your key and your identity are separate. If you lose your key, there can still be a social recovery mechanism, and we can talk about that too. But in this particular instance, what's going to happen is that you generate a key locally, but in addition to storing it in your browser's local storage, you also submit it in an encrypted form to the network that it can be retrieved with your username and the password. So if you go to another computer which doesn't have your private key in your local storage and you enter your username and your password, the necessary encrypted data will be loaded off the blockchain, decrypted in your browser, and placed in your browser's local storage. But
So
you don't have to use it that way. So this is not dependent on this mechanism. You can use a hardware key.
okay, but then that does mean that your security is based on the security of your password, because someone could try to brute force your password.
Yes, so it has the usual cryptographic protection mechanism like salted and iterated hashing and those things. But yes, you should choose a reasonably strong password. And also we have this idea that one thing that can mimic the, so if that happens, for example, with your Facebook account, you will email Facebook support. Now, in a decentralized application, there's no Facebook support, so whom you are going to turn to. And we have this idea that your initial point of contact is the person who invited you, because they apparently know something about the system more than you do, and they can have some sort of control over your account, which you can cut. It's up to you again. So you as the invited person can decide that, okay, now I have some better social recovery mechanism, or I trust my hardware key more than anybody else. So you can cut that umbilical cord if you want to. But initially, as a naive user, you can email to whoever invited you that, hey, let me call you over the phone. Somebody has brute forced my key. Could you please reset my password so that I can pick a better one? So if you, so now if you get to this, if you scan this QR code, then where you're going to get is something like this. And then you just need to authorize get login to be your user management. Oops, sorry, I clicked too early. So, so maybe you have already done that. So, where's my video? SOS, yes.
Isn't it about?
Okay, so this is a very primitive DApp example that you can try, and we screwed a little bit up because that's not the contract URL that we wanted to be there. But I think now we can. Yeah, it's this one. So the actual URL of the contract is this guy here. So, yep, another QR code. So here's the Rinkaby contract of the user management system. And if you look at this contract, then you can actually watch what happened when you registered, when you accepted the invitation, when you logged in, when you authorized your when you authorized your client. So all these things, they happened in the blockchain. But as you can see, I didn't have to send him any, Rinkeby test ether. So the onboarding process is actually very, very closely mimicking the Web2 onboarding process, that in the email you just get an invitation with a link on which you can click. So basically that's the demo that I wanted to show. And if you want to play with it, there are more invites available. And I think it's time to open for the Q&A. Yep.
We have time for one question.
Anybody else, maybe?
Well, you said that like the identity and the keys are different. Tell me about what is the identity. Is it a smart contract? Is there a smart contract under the hood for every identity? How
So the
work?
original idea was to use a proxy contract, but I was talked out of it. I think you were one of the people who talked me out of it. So instead of that, there's this smart contract which has a database of identities. So identity is basically a record in a smart contracts database. So there's no separate proxy contract for every identity, but there's one smart contract per social network. And you have reasonably cryptographically protected records from which those who have the appropriate credentials can kind of prove everything they need to prove. But, for example, you cannot scan the state of that smart contract and get all the usernames. That's not possible.
But can you find who sorry, I'm sorry, we're running out of time.
Okay, so who invited me? Yes, you can find that out.
Maybe if there is any more question, you can take them outside.
Yeah, we can take that offline, and we can certainly play with it and see how it works on the blockchain. Thank you for your attention. That's basically it.
I'm really sorry for catching you off like that. It's
No,
just
okay.
protocols,
Then, if you don't have a proxy, you can't have an EVM address for every user. Like you can't have something which says I want to send a token to a particular user. You can't have that because you can only use that for authentication.
No, you can. You can attach all the information to a user account.
But you're storing that inside the contract, inside the proxy contract.
No. There's this one big contract, which is the system, and you can attach public information to identities. You can, it acts like a database. You can say that, okay, if you know my username.
Okay, so but let's say I want to send you one token to your address, to